Okay, class, in this lesson, you will learn to solve problems with complex numbers. So let's go ahead and get started. Okay, so let's try a couple examples where we solve a quadratic equation using square roots, okay? So if we were to solve for a, where we have the problem x squared is equal to 16, what we would do is square root both sides, as you have learned in previous lessons. And when you square root both sides, we get x is equal to plus or minus 4, right? Because x is equal to 4 or x is equal to negative 4. Okay, so let's go on to example B. We're going to do the same thing here. We've got x squared is equal to negative 9, okay? So what we're going to do is square root both sides. And when we do, on the left side, we get x. And on the right side, we run into a slight problem. But what we could do is rewrite this as square root of 9 times square root of negative 1. Okay? So, and this works out to plus or minus, which means x is equal to plus or minus 3 square root of negative 1. This square root of negative 1 is called the imaginary unit I. And so in math, what we do is replace that square root of negative 1 with the letter I. Okay, so the answer here is going to be plus or minus 3i. Okay, that means that our answer is either equal to positive 3i or x is equal to negative 3i. Okay, so let's explore this imaginary unit I a little bit further. So in the world of complex numbers, the imaginary unit I is the principal square root of negative 1, as you saw, right? So whenever you have a negative square root of 1, that is equal to I. Now, what's also interesting is if you have I squared, that is really the same thing as square root of negative 1 times square root of negative 1, which is equal to the square root of negative 1 squared, which is the same thing as negative 1. Right? If you think about this, when you have a square root sign raised to the square or raised to the 2 power, they essentially cancel each other out, which means what you have left is just what's underneath the radical sign. In this case, it's negative 1. Okay, so we now know that I is equal to square root of negative 1 when we square I, okay, or multiply by itself twice, we get a value of negative 1. Now what happens when we go to I cubed? Well, I cubed is the same thing as I times I squared. We already know what I is, and I squared is negative 1, and so I cubed is just negative I. Okay, and lastly, if we go a little bit further to I to the 4th power, I to the 4th power is the same thing as I squared times I squared, and that is equal to negative 1 times negative 1, and that works out to a positive 1. Okay, so these 4 relationships is really important to remember. When you have a negative square root of 1, that is equivalent to I. Okay, so we already established that as the imaginary unit I. When we square it, that results in a negative 1. When you cube it, that results in a negative I. And then when you raise it to the 4th, that results into a positive 1. Okay, now an imaginary number is any number bi, or b times I, where b is a non-zero real number and I is the square root of negative 1. Complex numbers are numbers that can be written in the form a plus bi, where a and b are real numbers, and I is the square root of negative 1, as you've just learned. So complex numbers include all real numbers as well as imaginary numbers. Okay, so up to this point, prior to learning the square root of negative 1, every number that you've learned has been in what's called the real number world. Okay, now that we've introduced the square root of negative 1, that is the imaginary number, and the imaginary number belongs in the imaginary number world, and both the imaginary number world and the real number world they're both a subset of what's called the complex number world. Okay, so let's take a look at 3 examples here. Okay, first is we have a negative 6 plus 4i. Okay, we put this in the form of a plus bi, and so our a here is negative 6, and our b is a positive 4. Okay, and if you take a look at the next example, again, we have this number represented as a plus bi, or in the form of a plus bi, and our a here is 7, and our b here is negative 2. Okay, and then in the third example, we have 0.5i right here. Our a value is technically 0 because we want the complex number to be in the form of a plus bi. So it's really 0 plus, and then our b here is 0.5. Okay, so let's move on to example 2. Okay, so adding and subtracting complex numbers. So the question here is, what is the sum of 4 minus 7i and negative 11 plus 9i? Well, to do this, all we want to do is add them together. So this is 4 minus 7i plus negative 11 plus 9i. And to add those, we want to add what's common. So we're going to add the real numbers together. So that works out to 11. And my imaginary numbers over here work out to 2i. Okay, so then our sum here is going to be 11 plus 2i. And that is our answer for part A. Okay, now part B asks, what is the difference of 6 plus 8i and 2 minus 5i? Well, that is really the same as 6 plus 8i, okay, minus 2 minus 5i. Okay, so before we do anything, what we need to do is distribute this negative number across both of these numbers. So 6 plus 8i remain the same. Now we have a negative 2 and then a positive 5i because both these two negatives cancel each other out and they make a positive. Okay, so now we can sum the real numbers. These two numbers here, that works out to 4. And then these two numbers here work out to 13i. Okay, so then our difference here is going to be 4 plus 13i. Okay, and let me go back to this previous problem. I noticed an error here in that 4 plus negative 11 is not 11, but it's actually negative 7. Okay, so we should change that to negative 7. And that means that this would have to change also to negative 7. So hopefully, if you were following correctly, you would have caught that. So I'm glad I caught that throughout this lesson. So let's go ahead and move on to example 3, multiplying complex numbers. Okay, so multiplying negative 2.5i times the quantity 8 minus 9i is really the same as distributing these numbers, meaning we're going to take negative 2.5i times 8, and then we're also going to subtract negative 2.5i times 9i. okay? And negative 2.5i times 8 works out to negative 20i. And we're going to subtract a negative 2.5i. That's going to work out to 22.5 times I squared, okay? So these two negatives make a positive. This is why we have a positive. So now we have 2.5 times 9 is 22.5. We have I times I is I squared. Now, as you recall from earlier in the lesson, we know what I squared is, right? I squared is negative 1. And so therefore, this works out to negative 20i minus 22.5. Now, when we put these answers, we have to put it in the form of a plus bi form. Okay, so we're going to need to switch these two numbers around. So this works out to negative 22.5 minus 20i. Okay, so that is our answer for part A. And then for part B, we have 3 minus 2i times 3 plus 2i. Now this one is going to be interesting, and you'll see in a few minutes why this is interesting. So we're going to multiply these together. So that means we're going to multiply the first terms. Okay, so 3 times 3. Let me go ahead and just write these out. We're going to multiply 3 times 3 first. Okay, so that's 3 times 3. Then we're going to multiply the outer terms here. So we're going to multiply 3 and 2i. Okay, so that works out to 3 times 2i. Then we're going to multiply the inner terms. So these terms. So that's going to be negative 2i times 3. And lastly, we're going to multiply the last terms of each set. So we're going to multiply this and that. Okay, so that works out to negative 2i times 2i. Okay, so if we were to multiply these out, this works out to 9, okay? Plus, now what's interesting here is these two middle terms work out to 6i and negative 6i. And then the last term works out to negative 4 times I squared. Okay, now these two middle terms cancel each other out, so we can cross those out. And now we're left with 9 minus 4, and we know now that I squared is negative 1, so that's just negative 1. And then this simplifies to 9 plus 4, which is equal to 13. Okay, now when we set out to do this particular example, I said that this was going to be interesting. And you notice that this is a 3 minus 2i times 3 plus 2i. It is this set here is the same as this. The only difference here is we have a negative here and a positive here, right? But the numbers are essentially the same. In that scenario, when you have the same numbers but a minus and a plus in each of these sets, that is called a complex conjugate. Okay, so what is a complex conjugate? They are complex numbers with equivalent real parts, right? Real parts, equivalent real parts. So this is equivalent. This is a real, that's real. This part here, negative 2 is real, and positive 2 is real, okay? So equivalent real parts and opposite imaginary parts, right? Opposite imaginary. So we have a negative imaginary number and a positive imaginary number. Okay, so that is a complex conjugate. So for example, 7 minus 8i and 7 plus ai are complex conjugates. The real numbers are the same, the 7s are the same, the 8s are the same, and the imaginary parts are opposite, right? Negative I, positive I. This is also a complex conjugate. Negative 2 plus I and negative 2 minus I. The real parts, or the real numbers, are the same. You have a negative 2, they're the same. And then we have a positive 1 in here and a positive 1 in here. The only difference is the imaginary parts. This is a positive I and this is a negative I. So the imaginary parts are opposites. Okay, so given that, let's take a look at example 4. Okay, so we're going to simplify this quotient with complex numbers. Okay, so the question here is, how can you write this quotient in the form of a plus bi? Well, we have this 2 minus I as a denominator, and we just learned about the complex conjugate, right? So if we apply the complex conjugate concept here, we could change this to a real number denominator and thereby create a number in the form of a plus bi. Okay, so what do I mean by that? What we're going to do is multiply this quotient by 2 plus I over 2 plus I. Okay, now we can do that because 2 plus I over 2 plus I is essentially 1. So we're just multiplying this whole thing by 1. But we're changing the format of 1 into 2 plus I, and technically it's the complex conjugate of 2 minus I. And if we do this, then you'll see what will happen. Okay, so this works out to 10 times 2 plus I in the numerator, and then the denominator we're going to get 2 squared minus I squared. Okay, so let's go ahead and multiply out the numerator. This works out to 20 plus 10I divided by 4 minus negative 1. Okay, and in the top, in the numerator, we could factor out a 10 from each of the numbers. So this works out to 2 plus I. Okay, and then the denominator works out to 5. All right, now we have a 10 in the numerator, a 5 in the denominator, so we can simplify this by factoring out a 5. So this works out to 2, and this works out to 1, and so this answer is 2 times 2 plus I. Then multiplying that out, this works out to 4 plus 2I, which is exactly in the form a plus bi, which is what we were looking to do. Okay, so let's go ahead and move on to example 5. Factor a sum of squares. Okay, so the question here is, how can you use complex numbers to factor the sum of two squares? Okay, here we have x squared plus y squared. Now, up to this point, of all the techniques you've learned to factor, you have not learned how to factor the sum of two squares, right? X squared plus y squared. However, now that we understand how to work with complex numbers, we now have a new set of skills that will allow us to factor this. So let me show you how. Okay, so we can rewrite x squared plus y squared in terms of a difference of two squares, right? In other words, x squared minus negative y squared. Okay, and then you can think of negative y squared, this part here, as negative 1 times y squared. Since we know that negative 1 right here is the equivalent of I squared, we can replace that negative 1 with I squared. So in other words, x squared minus I squared y squared, which is really the same as x squared minus yi squared. Okay, so now what we have is a difference of two squares. We have an x squared minus, right, difference of this squared and yi squared, which, if you recall from an earlier lesson, this factors out to x plus yi times x minus yi. Okay, so that is our answer if we factor out the sum of x squared plus y squared. So this is the problem that we started out with, and using our new knowledge of complex numbers and the values of I and I squared, we are able to work out this factor as x plus yi times x minus yi. Okay, so let's take a look at this next example. How can you factor the following expression, 12x squared plus 3? Okay, so similar to part A, but the first thing we want to do is factor out a common factor. So meaning that we can factor out a 3 out of 12 and a 3 out of 3. So this works out to 3 times 4x squared plus 1. Okay, so now we can create a difference of two squares. Inside we have 4x squared minus, right, negative 1 and we know what negative 1 is. We know that negative 1 is I squared. So this works out to 3 times 4x squared minus I squared. Okay, notice that we replace this negative 1 with I squared. Now we have a difference of two squares. So then this factors out to 2x plus I times 2x minus I. Okay, and so this works out to be our answer. Okay, so let's go ahead and move on to our last example. Now we can apply everything we just learned to solve a quadratic equation with complex solutions. Okay, so the question is, what is x squared plus 4 equal to 0 work out to? What are the values of x? Okay, so we have, again, the sum of two squares. So we can change this to the difference of two squares. So we're going to manipulate this a little bit and say that this is x squared minus negative 2 is equal to 0, right? So that is x squared minus negative 1 times 2, which is equal to 0, okay? And again, you notice that we factored out this negative 1 out of this negative 2, right? This negative 1 times 2 gives us this negative 2. We're still subtracting that. And the reason we want to factor a negative 1 is because we want to include an imaginary number here. And we know that I squared is negative 1. So we can go ahead and replace that as x squared minus I squared times 2 is equal to 0. And we're going to switch this around. This is the same thing as minus 2I squared. That's equal to 0. And I forgot to include the square here and the square here, right? Because our original number is 4. So I should have had a minus 2 squared, 2 squared, 2 squared. Okay, so this is also 2 squared. Okay, so now we have a difference of two squares, right? This is x squared minus 2 times I squared is equal to 0. Here's our difference of two squares. So this works out to x plus 2I times x minus 2I, and that is equal to 0. And then what we would do is set each to 0. X plus 2I is equal to 0, or x minus 2I is equal to 0. And so x is equal to negative 2I, or x is equal to 2y. Okay, just to clarify, we subtracted 2i from both sides here. And on the other side, we added 2i to both sides. Okay, in case you didn't understand how I arrived at the answer. So this becomes our answer. X is negative 2i, or x is equal to 2i. Okay, hopefully that made sense. If any of this was confusing, which is very likely, please go back to the beginning of the recording and listen to this again. Thank you.